विद्यार्थी मित्रांनो, आजच्या आपल्या लेक्चरमध्ये आपण डिस्कस करणार आहोत टाइप्स ऑफ लिगँड्स. मागच्या लेक्चरमध्ये आपण कोऑर्डिनेशन कंपाऊंड्स हा चॅप्टर सुरू केला, त्याचं इंट्रोडक्शन पाहिलं आणि त्याच्यामध्ये आपण एक एक्झाम्पल पाहिलं सिस्प्लॅटिन नावाचं, की ज्याच्यात आपल्याला कळालं की कोऑर्डिनेशन कंपाऊंड हे एक असे कॉम्प्लेक्स मोठ्या आकाराचे कंपाऊंड्स असतात की ज्यांच्यामध्ये केंद्रस्थानी एक मेटल ॲटम किंवा आयॉन असतो आणि कडेने लिगँड नावाच्या स्पेसिस असतात की ज्या एकतर ॲटम असू शकतात, मॉलिक्यूल असू शकतात किंवा आयॉन असू शकतात. आणि या लिगँड ज्यांना म्हटलं जातं अशा स्पेसिस केंद्रस्थानी असलेल्या मेटल ॲटम आयॉनशी कोऑर्डिनेट बॉन्ड तयार करतात. आणि हा कोऑर्डिनेट बॉन्ड हा कसा तयार होतो तर ते लिगँड त्यांच्याकडे असलेली इलेक्ट्रॉन पेअर सेंट्रल मेटल ॲटमला किंवा आयॉनला डोनेट करतात आणि अशा पद्धतीने जो बॉन्ड तयार होतो त्याला आपण coordinate bond असे म्हणतो. The bond which is formed by the donation of lone pair of electron by the ligand to central metal atom or ion, that bond is known as coordination bond. And compounds which possess those types of bonds, those compounds are known as coordinate compounds. So in last lecture we have discussed about the ligand. So that the general idea of ligand is that it is such a species which is capable to donate electron pair to central atom or ion to form a coordinate bond. So that based on the number of donor atoms, there are two major types which are discussed in your textbook. For example, the first type is discussed, which is monodentate ligand. विद्यार्थी मित्रांनो, याच्या फक्त नावावरून सुद्धा तुम्हाला समजू शकेल की याच्यात मोनो म्हणजे सिंगल आणि डेंटेट. आता खरं तर डेंटेट म्हणजे दाताशी संबंधित शब्द आहे. आपल्याकडं गणपतीला एकदंत म्हटलं जातं म्हणजे मोनोडेंटेट. तर इथं तसंच दात या अर्थाने ती जी इलेक्ट्रॉन पेअर लिगँड डोनेट करणार आहे त्याच्यावरून त्याची कोऑर्डिनेट बॉन्ड तयार करण्याची कॅपॅसिटी ठरते. आणि म्हणून जर एखाद्या लिगँडमध्ये एक डोनर ॲटम असेल किंवा एक लोन पेअर ऑफ इलेक्ट्रॉन capable to donate in the coordinate bond अशी असेल तर अशा लिगँडला मोनोडेंटेट लिगँड असं म्हटलं जातं. म्हणजे द लिगँड विच हॅज वन सिंगल डोनर ॲटम or a lone pair of electron available to donate, that ligand is known as monodentate ligand. याचं उदाहरण आहे, सोपं आहे. उदाहरणार्थ क्लोराईडचा आयॉन. क्लोरीन मध्ये शेवटच्या कक्षेत 7 इलेक्ट्रॉन असतात, ते आपण दाखवू. 7 इलेक्ट्रॉन आणि 8वा इलेक्ट्रॉन जर क्लोरीनने एखाद्या कंपाऊंड मधून डिसोसिएट होताना घेऊन आला तर तो आयॉन तयार होतो, त्याला आपण म्हणतो क्लोराईड आयॉन. आता ही इलेक्ट्रॉन पेअर एखाद्या मेटलला ॲटमला किंवा आयनला दिली जाऊ शकते आणि अशा पद्धतीचा कोऑर्डिनेट बॉन्ड तयार होऊ शकतो. सो दॅट हिअर क्लोरीन हॅज a lone pair of electron. That means this chloride ion, which is considered as a ligand, is the species which has one donor atom or one lone pair of electron to donate. That is known as monodentate ligand. Another example which can be discussed here is of hydroxyl ion. You know that hydrogen is divalent in various of its example, but wherever it is divalent it carries couple of electron pairs. In hydroxyl ion it is attached at the one end to hydrogen, and at the another end if it is hydroxyl ion then the one electron of oxygen has not been utilized and also that oxygen has carried single electron from other species while dissociating. Means if it is dissociated from NaOH as a hydroxyl ion, it has acquired single electron of sodium. If it is dissociated from H2O, it has acquired single electron from hydrogen. In this way, it carries minus charge, and it is hydroxyl ion, and it also can donate a single pair of electron to form coordinate bond. Another example which we can discuss here of cyanide. Here the fourth electron of carbon is radical electron, and if it is cyanide ion, then it has also acquired single electron from any other opposite donor atom while dissociating as like cyanide ion, so that this is Cn minus, and here is also one electron pair available to donate, and it can form a coordinate bond with any metal. So these are the examples of monodentate ligand. They have single donor atom or single pair of electron to donate in the formation of coordinate bond. The second type includes many other types, and the second type is known as polydentate ligands, and the subtypes are bidentate, tridentate, tetradentate, pentadentate, hexadentate. That means we can say that polydentate ligands are ligands in which there are two or more than two donor atoms, in which we can discuss first example of bidentate ligand. Obviously it has two donor atoms. Example: CH2, CH2, NH2, another end NH2. This is ethylene and two amine groups. This is ethylene diamine. Both nitrogen atoms carry electron pair. Those can be donated to metal atoms, central metal atom, to form two coordinate bond, so that ethylene diamine is bidentate ligand. One more example which we can discuss here is oxalate ion, C2O4 minus minus. So it can be drawn like this, C2O minus, O minus. Here both oxygens at the terminal end can form a coordinate bond with any metal atom or ion, and therefore it is also bidentate ligand. In the same way, we can have several examples of tridentate, tetradentate and pentadentate ligand. We will discuss here one example of hexadentate ligand, and it is EDTA. EDTA means ethylene diamine tetraacetate. It has 6 donor atoms. For example, we will draw the structure: ethylene, CH2, CH2, diamine at the two ends, 2 nitrogen atoms, and tetraacetate means each this nitrogen carries 2 acetate ions. Here there are 6 donor atoms in this EDTA. First, this is second. Nitrogen carries electron pair, so this is third donor atom. This one is fourth donor atom. This is fifth donor atom, and this is sixth donor atom. So these are the types which were based on the number of donor atoms. But one more type is there in your textbook which has discussed as a third type, and that is different than those two types, and the third type is known as ambidentate ligand. It is quite interesting type of ligand. In this type, ligand have two donor atoms, but it can attach or it can form a coordinate bond by using a single site at a time. But it can use both sides with respect to different example. For example, we can discuss here nitrite ion, NO2 minus. It has two donor atoms. One is nitrogen, it also carries electron pair, and another is oxygen. It also carries lone pair of electron to donate and to form coordinate bond. For example, if this nitrite ion is attached with any metal by a coordinate bond in which the point of attachment is nitrogen, this ligand is known as nitrito because it is attached through nitrogen to this metal atom. But if the same ligand is attached by using oxygen as a point of attachment or as a lone pair electron donor to the central metal in that coordination compound, then the compound would be like this, and this ligand is known as nitrito O, and these are the two different ligands having same formula but different point of attachment. So such a ligand which has two donor atoms and which can be connected, which can connect with central metal atom by using both donor sites, but one time it can use single site of attachment. So this type of ligand is known as ambidentate ligand. One more example we can discuss here is thiocyano group or thiocyanide ion. It can connect with metal by using this point of attachment sulfur because it also carries lone pair of electron which can be donated in coordination bond, and another point of attachment could be nitrogen, and nitrogen can also donate a lone pair electron to form a coordinate bond. So this ligand is known as thiocyano, and this ligand is known as isothiocyanone. Here this is the ambidentate ligand because it has two donor atoms, but it can be connected to the central metal atom by using any one of them at a time. In two different cases, it can use two different points of attachment or two different donor atoms. Such ligand which has two donor atoms but only one is used in a particular example, that type of ligand is known as ambidentate ligand. Thank you.